Okay, and as Rocky mentioned, we're going to show how the method works in the Niobrara formation. And the objective here is to identify lithology in the Niobrara. For this analysis, we did it from the top Niobrara to the top caudal formations. We have multi-mineral petrophysical evaluation in 5 of the wells. Sorry, this slide goes off by itself. And we have 100 square miles of seismic data. Okay, so I'm going to take the 5 wells that are used to estimate the four lithofacies, and or I'm going to use the 5 wells to estimate four lithofacies, and we see that the wells have 2 fluids, in this case hydrocarbon and water, and 4 different rock types, being calcite, dolomite, silt, and clay. So when I take the petrophysical evaluation and do the sum of those, I get the following phases, or the following neurons. This would be the content inside the neurons. You can see, or I can see here, that the phases 1 has a high content of calcite, so I'm going to call this phases calcite. Phases 2 has high content of dolomite, so I'm going to call this phases dolomite. Phases 3 has about the same content of dolomite and calcite, so I'm going to call this, let's call it generic carbonate or carbonate. And then phases 4 has a higher content of clay. Okay, so the next step, so I have created here my lithophases. The next step is to verify these lithophases with the well logs, with the petrophysical evaluation, just as a corroboration that we have been doing things correctly. Before doing that, I would like to refer you to this image. We're going to be working with this image in the next slides. And this is the well that we have been working with. This in here would be the SOM of the seismic that was previously created. These here are the lithophases that we just created. And this here is the trough of the seismic data. Now here, what I note in here, or what I would like you to see, is that within this trough, we have this is still well data, but we have in here embedded here. We have two layers of clay, and then we show here also dolomite. Down in here we see calcite. What I'm trying to say is that we have a lot of events within one trough of the seismic data. Okay, that being said, let's now go to the verification of the lithophases to the petrophysical evaluation logs. And to do that, what I do here is we have here the neurons from the seismic. Here I have the calcite log from the petrophysical evaluation, and here I have the phases that we just computed. And I have in here a baseline of 0.55, 55%. This will be this baseline. And I see that all the points with calcite higher than 55% match the phases here and here. I do the same with the dolomite. The dolomite, in this case, the baseline is 45%. And I can see that, this matches very well here from the well logs and the phases. And the same with the clay. So I think that that gives confidence that the SOM from the well logs did what it was supposed to do. So now what I'm going to do is that I'm going to do the correlation. I am going to correlate or to cross-reference the phases with the neurons and obtain a lithophases topology displays or maps. So what this is saying is that when I take these neurons and I select this neuron, I'm going to have a probability of 57% of that neuron being in this case dolomite. This would be calcite, this would be carbonate, and these two would be shale. And also display as a tone of the color of the neuron the probability of each one being the lithology or lithophases of this particular color. Okay, so let's now look at the real data, the seismic. This is the seismic in one of the lines, and this is the well. The log that you're seeing here is for reference, and it is the same as you're seeing here. These are the neurons, And then in here, I have the self-organized maps before the sum to log correlation or the sum to faces correlation. And then in here, I have the sum to faces correlation. And I want to compare this with the well log. And what I see here is right here is this again, this log is these neurons from the log. You can see here we have carbonate in here. We have here two stringers of shale. Right here is one, right here is the other one, embedded in dolomite. Right here is the dolomite. We have here carbonate, which would be this brown carbonate, some dolomite, another carbonate, and then we'll get into the calcite here. Then here we get again the carbonate, what we're calling carbonate, the dolomite. We are missing this stringer of clay in here. We have again carbonate topping the calcite, and then the calcite here. So I think that this is a very good correlation. And importantly, or you can see here, this is a trough, and within this trough we are getting all this information from the SOM. And you can see this and the next image. You can see a verification of this. So take a look at this, and then these are the same. This is the same, but in the seismic, you can see the amount of information that we're getting in the trough. I think that's very good. Okay, now what we are seeing here is the same, the same data, but in this case in time slice. Right here at 1.54 seconds is the seismic. This right here is the self-organized map, and this here is the time slice. And from the time slice, we see here, sorry, the sum to lithofacies correlation. And here you can see this has a high probability or a higher probability of being dolomite, the same as this, but it's more probable that this is dolomite because this is darker green than this green. The same in here, this is calcite, but the probability is higher that this is calcite because it's dark, and this is also calcite because this is darker yellow than this yellow down in here. So we're seeing here not only the lithology or the lithofacies, but also a measure of the probability of that particular location being that lithofacies. And I would like to take over or do a little bit more on the on probability and on the lithofacies. And for that, I would like to show this. This is a zoom of what we saw before. This here is clay. This again is clay in here, and notice how this is broken. And in this area, I would expect that this would be blanket clay, not cut off gray like this. So what I'm going to do is I'm going to take a closer look at this, and here I start by looking at the topology, the lithofacies topology, and then noting the probability. So here it's difficult to see, but there's actually two colors in here. This here that follows, that continues with the clay is neuron 14, has a 46% probability of being dolomite, and this 15, which is over here, has a 77% probability of being dolomite. Now, what I'm going to do is that I'm going to do a similar map, but considering only the probability of clay. When I do that, I can see that neuron 14 as well has 46% probability of being clay. So the dolomite and the clay have the same probability. In here, the dolomite was chosen. I guess it was the order in which it was computed, but these two have the same probability. And to illustrate this, I'm going to jump now to show you the image in 3D viewer. Just a minute. Let me see. Okay, so here we have the same image that we were seeing. And what we had mentioned here is that, what we had mentioned here is that neuron 14 and neuron 7 had the same probability of being clay. Let me look here the full. And I said that 14 and 7 have the same probability of being clay. When I look at this, you can see that they are continuous. That is, they are the same probability, and they are going to, it's basically the same formation. Now I can see the, the clay continuously. Now we also mentioned that 5 was also, we said 5, 6, 7, 5, 4, 5, 6, 7, and 14. So let's take a look. Right here is 4. And yeah, I mean, you can consider it part of the clay. In this case, I'm not going to include it because it's mostly, the very steeply dipping parts probably associated to faults. We mentioned 5. 5 appears to be mostly the lower shale that we were seeing, so I'm not going to consider it for now either. And 6 right here, it's still part of the same formation, but for now I'm just going to stick to 14 and 7 here. Okay, so now I want to see it, extensionally. To see it extensionally, first of all, I'm going to bring everything again. To see it extensionally, what I'm going to do is that I'm going to bring a horizon, and I am going to extract the, the neurons from the horizon. Right here, you can see the extent of, let me see, just a minute. Let me bring again here this, and so this is going to be the color selector for, this is going to be the color selector for the horizon that I'm working here. I'm going to select 14 and 7, and this is what I would expect to see. It's more extension, but still I don't like the green and the purple colors, or the gray colors there. So what I'm going to do is that I'm going to bring now the color map of the probability of having clay. Okay, so that's the color map, the probability of being gray, and I'm going to select again 14 and 7, and now I get a more reliable, a more yeah, let's call it reliable display of the extent of the clay in the area.